4 inequalities in one triangle. All right, so example 1, draw a right triangle and a non-right triangle. How is the largest angle measure of each triangle related to the side lengths? Okay, so we'll do a right triangle. Let me try that again. Okay. So here's our right triangle. So our right triangle, our largest angle is the right angle. Because these two angles would be smaller. And then our largest side is opposite. Okay, let's look at a non-right angle. Okay, so our largest angle is this one. And our largest side is going to be the side opposite that. Okay, so our largest side is always opposite the largest angle. Which angle measure appears to be the smallest in MNP? How is it related to the side lengths? Okay, we're looking for the smallest one. So it appears that angle N would be the smallest. And if I'm looking at the side lengths, my 8 feet is the smallest side. So angle N is the smallest. And the opposite side is the smallest. Our unequal sides theorem. If two sides of a triangle are not congruent, so they're not equal, then the larger angle lies opposite the longer side. All right, so next we're going to use the unequal sides theorem. To support a triangular piece of a float, a brace is placed at the largest angle and a guide wire is placed at the smallest angle. Which angle is the largest? Which angle is the smallest? Okay, so we can tell that our 10 is the smallest side. That means angle B is the smallest angle. And then our 13 is the largest side. So our angle C is the largest angle. Which angle is the largest? So looking at our diagram, which angle would be the largest? So our 14 is the largest side, so angle E would be the largest. Which angle is the smallest? And I think I lost a side label. This should be D. Okay. So side EF is 8, and it is opposite angle D, so that means our smallest angle is angle D. Our converse of triangle inequality. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay, Okay, so this time if we know the angles, then we will be able to determine which side is either larger or smaller. Okay. We want to prove the converse of triangle inequality theorem, so we're going to do statement and reasons. Zoom in. All right, so we are given that the measure of angle J is larger than the measure of angle G. We need to prove that side GH is larger than HJ. Okay, so we want to assume that J or GH is less than or equal to HJ. So we're making an assumption. Okay, because of that assumption, that means that GH could equal HJ by definition of congruence. Okay, if GH equaled HJ, that would mean that triangle GHJ is isosceles. And if the triangle is isosceles, we're proving that by definition of isosceles. Okay, and if we have an isosceles triangle, then angle J, the measure of angle J, would have to equal the measure of angle G, which would be true by the isosceles theorem. Okay, so for this assumption is proving that the measure of angle J could equal the measure of angle G, which contradicts that the measure of angle J is greater than the measure of angle G. So that would prove that the assumption is false. All right, or try it. To complete the proof of the theorem, show that assuming GH is greater than HJ leads to a contradiction of the given condition that the measure of angle J is greater than the measure of angle G. So we're going to do a similar proof. So we are going to make the assumption that angle J is congruent to the measure of angle G. And if the measure of angle J is equal to the measure of angle G, that means that angle J is congruent to angle G by definition of congruence. And if angle G is congruent to angle J, that means that the triangle is isosceles. That is by definition of isosceles. And then finally, if it is an isosceles triangle, that means that GH could equal or would equal HJ by isosceles triangle theorem. Okay. All right, example 4. Which side of triangle KLM is the longest? Okay, so right now we only have 2 of our angle measures, but we know that we can find the measure of angle K because all of the angles inside the triangle have to add up to 180 degrees. So I can take 180 degrees, subtract off the 2 angles that I know. So that would give me 68 degrees for the measure of angle K. We are looking for the longest side. Well, my 68-degree angle here is the largest angle, so that means that LM is the longest side. All right, identify the sides of triangle NOP. Which side is the longest? Again, we need to find our missing angle here. So my missing angle would be 57 degrees. My longest or my largest angle is the 65, so that means my longest side is OP. Which side is my shortest? Well, my smallest angle is the 57 for angle O. The shortest side is NP. Right, triangle inequality theorem. The sum of the lengths of any 2 sides of the triangle is greater than the length of the third side. All right, so example 5. Which of the following sets of segments could be the sides of a triangle? So we want to take the smaller 2 sides of the triangle and add them together to see if our larger one could be part of it. So we're going to take the 18 plus 19, which would get us 37. So our triangle cannot have a third side that is larger than 37. So 37 is less than 40, so this cannot be a triangle. Because my 2 smaller sides added together have to be less than or equal to the largest side. And 40 is larger than 37. Okay, let's do our second one. We're going to take the smaller 2 sides. That would equal 70. So this time 70 is larger than 66. So this can be a triangle. Okay, can a triangle have side lengths of 16, 39, and 28? I'm going to take my 2 smaller sides, 16 and 28, and I'm going to add them together to make sure that they are greater than or equal to the 39, to the 39. So I get 44. Well, 44 is larger than 39, so yes, this can be a triangle. Okay, let's look at B for the example. A triangle has sides that measure 11 and 16. What are possible lengths for the third side? Okay, so we need to assume two things. We need to solve this twice. We need to assume that our x is either the largest side or that it is one of the two smaller sides. Okay, so first we're going to assume that the x is one of the two smaller sides. So I'd have x plus 11 because 11 is the smallest. And that needs to be greater than what would be the largest side, the 16. Okay, now I'm going to solve for x. So that means that x would have to be larger than 5. Okay, our second part of this, we want to assume that our x is the largest side. So then our 11 and our 16 would be our two smallest sides. So 11 plus 16 would have to be greater than x. Simplify, I'd get 27 is greater than x. I'll put all of these together then. I'm going to flip this inequality. It was opening towards my 27. It's still going to open towards my 27. I'm going to flip this inequality. My x is greater than 5. It was opening toward my x, and it still is. Now I can just squish this all together. So my 5 is less than x. Well, they're the same x's. So then x is less than 27. So that means that x has to be somewhere between 5 and 27. All right, B for our try it. A triangle has side lengths that are 30 inches and 50 inches. What are the possible lengths of the third side? Okay, so again, we are going to assume that our missing value is one of the smaller sides. So x plus 30 is the smallest one they gave us, is greater than 50. Okay, so x has to be greater than 20. Now we're going to assume that x is the larger side. So 30 plus 50 is greater than the side that we don't know, which would be the largest side. Flip these to make it easier to put all this together. So that means that x has to be between 20 and 30, or and 80, 20 and 80.